Welcome to the debate. In 2022, something really bizarre happened in the academic world. Like in just one single year, researchers published 18% of all the knowledge ever written about the metaverse over the last 3.5 decades. I mean, think about that scale for a second.
Yeah, it's staggering. And, we aren't talking about a short timeline here. We are diving into the completed Metaverse Project 2023 today, which is this incredibly exhaustive bibliometric analysis. It maps out 128,858 academic records drawn directly from the Web of Science core collection. Like, it covers everything from 1987 all the way to 2022, spanning 196 countries.
Right, so we finally have a satellite view of this entire landscape, but here's the multi-trillion-dollar question that the data forces us to confront. Are all these scientists and engineers actually building a unified, interconnected digital universe? Or, and this is the crux of our disagreement today, are they just slapping a trendy buzzword onto completely separate technologies that have, frankly, nothing to do with each other?
It's a vital distinction. From my perspective, when you look closely at this massive data set, it reflects a semantic clustering of mature, isolated tools. We're talking about things like virtual reality and blockchain.
Yeah.
They are being adopted independently across different academic disciplines. So the data severely questions whether a truly unified ecosystem, this so-called metaverse, has been realized at all, or if it's just a convenient umbrella term.
I mean, I see why you think that, but let me give you a different perspective. I look at this exact same network architecture, and I see absolute proof of a unified architecture of convergence.
Okay.
We are seeing artificial intelligence operating as a structural bridge, integrating all those diverse technologies into a completely new, higher-level ecosystem. It's not just a buzzword, it's a functional grid.
Well, let's dig into what that grid actually looks like, because the timeline itself is fascinating. If we want to understand what is happening now, we have to look at the massive historical expansion the data maps out.
Absolutely. There is a definitive inflection point in 2018. Like before 2018, the research was incredibly specialized.
Mostly engineering.
Right. You had 30 years of computer scientists essentially just, laying asphalt and running copper wire. That's the foundational tech research. But post-2018, everything exploded. We saw an aggressive 31.32% annual article growth rate.
The sheer volume of output completely transformed.
Yeah, but it's not just the volume, it's who was suddenly doing the publishing. This wasn't just more engineering papers. The technology bled out of computer science and expanded into 175 out of 254 possible academic subject categories.
Wow, 175.
Exactly. It completely took over the human sciences. We saw a definitive shift from building the mechanics, which historically held about 67% of the papers, to actual human application.
So you're talking about the explosion into the life sciences and social sciences.
Precisely. The data shows a 15.4% share in life sciences and biomedicine alone. And that spans 73 highly specific sub-areas. Everything from surgical training to stroke rehabilitation.
Right.
Then you have another 10.6% in the social sciences. Education alone produced almost 7,000 papers. Think of it like a global city grid. After 2018, hospitals, schools, and banks actually moved in and started building on top of the foundational tech. They created an interdependent ecosystem designed to solve complex human problems.
Okay, I hear the numbers, and the cross-disciplinary adoption is incredibly impressive. But I think we might be misinterpreting what expansion actually means here. Like, expansion does not necessarily equal structural integration.
How so?
Well, just because a hospital buys a VR headset doesn't mean they're plugging into the matrix,
But they aren't just buying headsets. They're integrating the technology into their core workflows.
Right, but I come at it from a different way. Your city grid analogy implies a shared, interactive infrastructure. The crucial question is this actually a bustling, integrated city where the hospital talks to the bank?
Or is the data just showing us a bunch of separate islands that happen to be buying their generators from the exact same company?
What makes you think they are separate islands? The research output is grouped together.
They are grouped together by a semantic umbrella, sure. But when we look at the actual semantic evolution mapped in the study, a huge division emerges. The analysis draws a very clear distinction between the top 10 technological pillars and the emerging 4 concepts.
Okay, let's clarify those for the listener. The top 10 pillars include things like virtual reality, blockchain, augmented reality, digital twins, IoT, smart contracts, security, mixed reality, simulation, and AI.
Correct. Those are the concrete tools. And then you have the emerging 4, which are the broader concepts: Metaverse, XR, virtual worlds, and Second Life. Now, the study dives into the text analysis of author keywords to see how these terms interact. And the most frequently occurring concepts by far are VR and blockchain. But here is the catch. They are operating as isolated tools. The specific term metaverse didn't even emerge as a significant node in this network until around 2010.
But eventually it did emerge, which, shows convergence.
It shows a new keyword became popular. But to understand if they are actually converging, the study uses something called a Phi Coefficient.
Right, the binary correlation.
Exactly. For those unfamiliar, think of the Phi coefficient like a digital stethoscope that listens to how often 2 words show up in the same room together. Like if VR and surgery are always at the same party, but blockchain is across town at a different party, the Phi coefficient catches that.
Right. It looks at the likelihood of 2 terms appearing together versus separately.
And what it reveals is heavily distinct clusters.
But thematic clusters are perfectly natural in any large field of study. I mean, that doesn't disprove a broader ecosystem.
These aren't just themes, though. They are walled gardens. The data shows that VR is heavily, almost exclusively correlated with terms like rehabilitation, surgical simulation, and presence. Meanwhile, blockchain is clustered in a completely different neighborhood with Ethereum, distributed ledgers, and smart contracts.
Okay.
So the data maps distinct silos. The surgical VR simulator is not interacting with the Ethereum smart contract in any meaningful way in the literature. So calling it an integrated city grid is an illusion. It's just a shared vendor.
I'm not sure I buy that conclusion, because you are heavily relying on the correlation of frequency. You are looking at how often words appear next to each other. But if they are just isolated islands, how do you explain the bridge? Because the network architecture data actually found a massive central connector linking all these islands together. Artificial intelligence.
The methodology there is fascinating, I'll admit, but we really need to unpack how it defines a connector.
We do, because the study makes a crucial empirical distinction between frequency and centrality. While you are right that VR and blockchain are the most frequent keywords in pure volume, the analysis of eigenvector centrality tells a completely different story about the actual structure of the research.
Let's explain eigenvector centrality because it's a dense concept. It essentially measures a node's influence based on its connections to other highly influential nodes, right?
Exactly. It's the difference between having 1,000 casual acquaintances versus having 5 friends, but those 5 friends are the president, the head of the UN, and the CEO of Apple.
That's a good way to put it.
It doesn't just count how many connections you have, it looks at the quality and influence of those connections. And the eigenvector centrality analysis definitively proves that artificial intelligence is the paramount connector node.
In terms of citations and keyword links, yes.
Yes, in the actual fabric of the research, AI acts as the central hub bridging those seemingly separate islands. Let's look at the mechanism of how this actually works. If you have a surgeon using a VR interface, that's one pillar, to operate on a digital twin of a human heart, which is being fed real-time data by IoT sensors, that's 2 more pillars.
Right.
How do those things actually talk to each other? They use AI. AI is the invisible engine translating those massive, complex data sets from the sensors into visual feedback in the VR headset in real time.
That is a highly sophisticated use case, definitely.
But it's exactly what the data shows. AI connects the infrastructure layers directly to the real-world applications. It is the gravitational center holding the established infrastructural pillars together. It translates, it renders, it secures.
Okay.
This proves structural interconnectivity. We aren't just looking at parallel clustering. We are looking at an integrated ecosystem where AI is the central nervous system.
That's a really compelling argument, and I absolutely agree that AI is the engine processing that data. But have you considered what AI actually represents in modern computer science? I question the fundamental assumption being made about AI's unique centrality in building a metaverse.
What do you mean? The data explicitly shows it bridging the clusters we just talked about.
That's an interesting point, though I would frame it differently. AI is the gravitational center of all modern computing, period. It is not unique to the metaverse.
Sure, but
If you ran an Eigenvector centrality analysis on global supply chain logistics, or mobile banking, or climate change modeling, AI would also show up as the paramount connector node.
we aren't analyzing global supply chains. In this specific dataset of 128,858 metaverse papers, AI is specifically linking the metaverse pillars.
Right. But is AI connecting these nodes to deliberately build a unified, interoperable metaverse? Or is AI just a universal utility that is naturally being utilized by all digital technologies independently? Like, let's go back to your hospital and bank analogy.
Okay.
If a VR rehabilitation clinic uses machine learning to track patient physical progress, and a blockchain network uses machine learning to detect fraudulent transactions, they both connect to the AI node in the visualizer.
Right, because they are both utilizing the same computational foundation.
Exactly. But they still aren't interacting with each other. The VR clinic is entirely blind to the blockchain network. The AI is just the electricity on the separate islands. It's powering both of them, yes, but sharing the same electricity doesn't prove the islands have formed a single unified nation. They are still operating in silos.
But they are interacting, and that brings us to the semantic evolution mapped in the study, specifically regarding those emerging four concepts. You argued earlier that the metaverse was just a buzzword for isolated tools.
I did.
Well, the bridge between these distinct technologies is actively forming right now. The data identifies extended reality, or XR, as the critical new frontier.
XR being the fusion of augmented reality and mixed reality into a more seamless spectrum.
Yeah. Yes, and it's doing exactly what you claim isn't happening. It's conceptually and technologically fusing these tools into a unified, immersive framework. The research is moving past just isolating someone in VR goggles or just giving them a basic AR overlay on their phone.
Okay, I see where you're going.
XR requires the interoperability of IoT, digital twins, and AI to function at all. And we know this integration is becoming a reality because of what the dataset shows us about future implications.
You mean the shift in focus toward the end of the timeline?
Exactly. There is a massive spike in research regarding the consequences of this fusion. Specifically, the data identifies three essential ethical pillars that are suddenly dominating the literature: privacy protection, digital safety, and moral responsibility.
Which are absolutely vital considerations when you are talking about spatial computing and persistent data tracking.
Right. But think about why they are suddenly so vital. They are only vital because the technologies are merging. You don't need a unified theory of moral responsibility or complex digital safety protocols for a standalone offline VR surgical simulator. I mean, the stakes just aren't that high.
Because the data is localized.
Exactly. But you do need those ethical pillars when that surgical simulator is suddenly connected to remote IoT devices, secured by a decentralized blockchain, and processed by AI in a persistent digital space where deeply intimate human biometric data is vulnerable.
That makes sense.
This sudden explosion of research into interoperability, security, and governance proves that structural integration is happening. The researchers are scrambling to build the guardrails because the walls between the silos are coming down.
I agree entirely on the necessity of those ethical mandates for human participation. The privacy concerns surrounding data-intensive immersive environments are staggering, especially when we talk about education and healthcare. But I have to point out a fascinating, almost bizarre quirk in the data regarding those emerging four concepts. And I think it severely challenges this narrative of a sleek, cutting-edge, integrated frontier.
I'm curious where you're going with this.
we talked about the emerging four: Metaverse, XR, virtual worlds, and, get this, Second Life.
Yes, the digital platform.
A platform that launched over 20 years ago. The bibliometric network shows a massive resurgence of this specific node in recent years, heavily tied to higher education and social network analysis.
Wait, so with billions of dollars being poured into Web3 and these advanced VR prototypes, to understand how humans will actually behave in the metaverse, academics are dusting off Second Life?
Exactly. Think about the irony here. If researchers in 2022 are still relying heavily on an aging, compartmentalized platform from the early 2000s to study how digital societies function, it tells us something profound about the current state of the technology.
That it serves as a reliable baseline for studying digital sociology?
No, it tells us that the fully integrated, interoperable metaverse you're describing is basically a ghost town right now. It doesn't actually exist yet in a form that can be rigorously studied at scale. The fact that the literature has to pivot back to Second Life to observe actual human socialization proves that the true metaverse is still just an emerging semantic horizon. It's a theoretical destination, not a completed architecture that researchers can analyze and practice.
I'm sorry, but I just don't buy that interpretation. Let me tell you why.
Go ahead.
You are looking at the use of Second Life as a symptom of failure, but you're ignoring the mechanism of scientific research. Why do sociologists study historical data?
To establish longitudinal trends.
Exactly. Researchers are using Second Life data because it offers longitudinal behavioral data spanning decades. If you want to understand how a digital economy functions or how digital identities evolve over 10 years, you can't study a VR platform that was invented 6 months ago.
Right, you need a long runway.
You need historical data. The fact that they are applying those longitudinal findings to the new XR frameworks doesn't mean the new architecture isn't being built. It means they are trying to build it intelligently using past behavioral models.
I see the logic there, but it still highlights a massive gap between the theoretical value of convergence and the empirical reality on the ground. The literature is projecting a beautifully unified future, this shared city grid, but conducting its actual behavioral experiments on isolated legacy platforms or highly localized VR tools.
The metaverse of an interoperable reality remains a conceptual umbrella in the data, not a built environment.
So if we step back and look at the entirety of Metaverse Project 2023, we are fundamentally looking at the same map, but seeing two very different landscapes.
We really are.
From my reading, this exhaustive analysis of over 128,000 records reveals a definitive structural shift. That 2018 multidisciplinary pivot wasn't just a fleeting trend. It was the moment the technology expanded to encompass nearly 70% of all academic subjects.
Yeah.
And when you look at the network architecture, specifically how artificial intelligence functions as the central Eigenvector connector, it explains how we have moved past isolated technological pillars. We are witnessing an architecture of convergence, where AI bridges IoT, VR, and digital twins into an actively integrating ecosystem. The ethical guardrails are being built precisely because that integration is happening.
And coming at it from the other side, while the academic output is undeniably vast and the cross-disciplinary adoption is incredibly impressive, we have to respect the rigorous correlation data. The Phi Coefficient tells a clear story of semantic clustering. We are seeing distinct, mature technologies being adopted in parallel silos. A hospital using VR is not structurally integrated with a bank using blockchain. And the integration you see through AI is likely just an artifact of AI's universal utility in all modern computing. Metaverse remains a future trajectory, beautifully imagined, but not yet realized.
You know, despite our disagreement on the structural reality of the network, I think where we do find absolute convergence, both in the data and in our interpretation, is the profound transition of what this research is actually trying to accomplish. It has fundamentally moved from purely mechanical engineering toward deeply human applications.
Absolutely. The shift away from just figuring out how to render 3D graphics and moving into the life sciences, the 73 sub-areas of biomedicine, the massive output from the education sector. The technology has finally found real-world application.
It's no longer just about laying the asphalt. It is about understanding how technical mastery can solve complex human problems across 175 academic domains, healing patients, training surgeons, educating students across borders.
And navigating the immense ethical realities of doing so. The future of this entire field, whether it remains in parallel silos or becomes a unified city grid, will entirely depend on whether we can build privacy protection and digital safety into the foundations before the walls come down.
Which means there is still so much more to explore in this material. The true value of convergence, however you define it, is still unfolding in real time.
It is a map that is very much still being drawn.
Exactly. When cartographers first map a new world, the debates over the boundaries are just the beginning. The real work is understanding how the disparate pieces eventually form a single habitable space.